Assalamualaikum and hello everyone. My name is Nurul Fadilah binti Muhammad Azri, metric number S48420. Now, I would like to present about transformer voltage regulation and efficiency. Because a real transformer has series impedance within it, the output voltage of a transformer varies with the load even if the input voltage remains constant. The voltage regulation of a transformer is the change in the magnitude of the secondary terminal voltage from no load to full load. Output voltage of transformer varies with load. This is the equation for voltage regulation, which is secondary no load voltage minus secondary full load voltage over secondary full load voltage times 100%. At no load, secondary voltage equal to primary voltage over A, which is current ratio. Thus, voltage regulation equal to primary voltage over A minus full load voltage over full load voltage times 100%. In per unit system, voltage regulation equal to primary per unit voltage minus secondary full load per unit voltage over secondary full load per unit voltage times 100%. The voltage regulation of an ideal transformer is 0. Next, the transformer phasor diagram. To determine the voltage regulation of a transformer, it is necessary to understand the voltage drop within it. Usually, the effect of the excitation branch on transformer can be ignored, and therefore only the series impedance need to be considered. The voltage regulation depends on the magnitude of the impedance and on the current phase angle. A phasor diagram is often used in the voltage regulation determination. The phasor voltage is assumed to be at 0 degree and all other voltage and currents are compared to it. Considering the diagram and by applying the Kirchhoff voltage law, the primary voltage is primary voltage over current ratio equal to secondary voltage plus R equation secondary current plus JX equation secondary current. Next, figure 1 show a transformer phasor diagram is a graphical representation of this equation. Figure 2 show a transformer operating at a lagging power factor, while Figure 3 show a transformer operating at a leading power factor, which is secondary voltage is lower than primary voltage, so voltage regulation greater than 0. Next, Figure 4 show a transformer operating at a leading power factor. If the secondary current is leading, the secondary voltage can be higher than the referred primary voltage, so voltage regulation less than 0. Next, the table shows the summarized possible values for voltage regulation versus load power factor. For lagging power factor, primary voltage over A greater than secondary voltage, while voltage regulation greater than 0. And for power factor of unity, primary voltage over A greater than secondary voltage, while voltage regulation greater than 0. And lastly, for leading power factor, secondary voltage greater than primary voltage over A, which is current ratio, and voltage regulation less than 0. Since transformer usually operate at lagging power factor, which is actual power over apparent power, a simplified method is introduced. For lagging power, the vertical components related to voltage drop on R equation and X equation partially cancel each other, which is angle of primary voltage over A is a very small. Next, the transformer efficiency. The efficiency of a transformer is defined as efficiency equal to P out over P in times 100%, or can be declared as P out over P out plus P loss times 100%. The same equation describes the efficiency of motors and generators. Considering the transformer equivalent circuit, we notice that there are three types of losses, which is copper losses, hysteresis losses, and eddy current losses. For copper losses are accounted for by the resistor, while hysteresis losses are accounted for by the resistor R, and eddy current losses are accounted for by the resistor R. Since the output power is P out equal to secondary voltage dot secondary current cos secondary theta, the transformer efficiency is equal to the secondary voltage dot secondary current cos theta over copper loss of power plus core loss power plus secondary voltage dot secondary current cos theta times 100%. So, here are some of questions that we can do as a revision. Thank you.